Hi all, today you are going to see what are the basic concepts needed for finding the answers for the questions from exercise 1.2 from the real numbers chapter. First one, fundamental theorem of arithmetic. This theorem states that every composite number can be expressed as the product of primes, and this prime factorization is unique apart from its order. Every composite number can be expressed as the product of primes. This factorization is unique apart from its order. Okay, this theorem says that if any composite number is given to you, you can express it as the product of prime numbers. Let us try with the number 30. 30 is a composite number. Composite number means it will have more than two factors, and prime number will have only two factors, the number itself and 1. So 30 we are going to express as the product of primes. For this you can use the long division method, and when you divide, you will divide only by the prime numbers. First I'm going to divide this by 2. 15 times. Then again I'm going to divide by another number 5. And I'll get 3. By 3 when I divide, I get 1. See, these all are prime numbers 2, 5 and 3. So this 30 I can write as 2 into 5 into 3. If I start dividing this 30 by 5, I'll get 6 times. Then by 2 if I do, I'll get 3. Then by 3 if I divide, I'll get 1. Then I'll stop. Now this same 30 I can express as the product of 5 and 2 and 3. Now you can see the similarities. The factors are same. That's why it is given. The factorization is unique. Apart from its order, we can see the order is changed. Here 2 5s are, here 5 2s are. In any way, the order can change. This is the fundamental theorem of arithmetic. Like next one, we are going to see if an exponent of a number is given, to check whether the value of this number digit end with 0 or not. I'll show you with an example. If 6 power n is given and you are asked to check whether the value of this number end with the digit 0, it is easy. First you will find out the prime factorization of the base. What is the base here? 6. So I'm going to find out the prime factorization of this base 6. For that I must divide this by prime number. First I'm going to divide by 2, I get 3. And by 3 when I divide, I get 1. So this I can write as 2 into 3 the whole power n. Then again I can expand this as 2 in 2 power n into 3 power n. We have the prime factors 2 and 3. One factor is missing, 5. If any number end with 0, it must have two factors, 2 and 5. We can have more factors, but compulsorily 2 and 5 must be the factors. Otherwise, it will not end with 0. For that, I can give you one more example. You can say any number which end with the digit 0. 150, for example, you can take the prime factorization of 150. By 2 if you divide, you will get 75. By 5 if you divide, you will get 15. And by 3 if you divide, you will get 5. And by 5 if you divide, you will get 1. You can see the prime factorization of 150 is 1, 2 into 5 into 3 into 5. However, 2 and 5 are factors. So it will end with 0 only. That already the digit is ending with 0. Those numbers I took for showing the prime factorization of the number end with 0 will have the factor as 2 and 5. Okay. The third one, you can take any two numbers and find out the HCF and LCM of those two numbers. When you multiply the HCF and the LCM of those two numbers, it will be equal to the product of the given two numbers. Let us take two numbers. 6 and 4. Okay. Now we are going to find out the HCF of 6 and 4 using the long division method. 6, 4. The common factor of the 6 and 4 is 2. So by 2 when you divide, you will get 3. This 4 when you divide, you will get 2. Now we don't have any other common factor other than 1. So we stop here and we write HCF of 6, 4 as 2. Now we are going to find out LCM of 6 and 4. When you find out the LCM, non-common factors also, you will multiply. So by 3 when you divide here, you will get 1 time. And this non-common factor also will take out 2, 1, 1. Now we stop. When you multiply these all, 2 3s are 6, 6 2s are 12. So we found HCF of 6 and 4 and LCM of 6 and 4. Now we are going to multiply HCF and LCM. HCF into LCM equal to what do we get? 2 into 12, 24. Now we are going to find out the product of the two given numbers. Product of 6 and 4, that we know 24. Now from this we can get HCF into LCM equal to the product of two given numbers. So today we learned three basic concepts which are required for finding the answer for the questions given in exercise 1.2 from the chapter real numbers. What are those? First one, fundamental theorem of arithmetic. Every composite number can be written as the product of primes, and this prime factorization is unique apart from its order. The second one, any number which ends with the digit 0 will have the prime factorization as 2 and 5, and more factors it can have, but 2 and 5 must be 2 of its factors. The next one, when you multiply HCF of two numbers and LCM of two numbers, that will be equal to the product of those two given numbers. I hope you all understood these three basic concepts which are required for finding the answer from exercise 1.2. So in next video you can see the exercise 1.2. Thank you for watching.